if there is a mixture of gases, if there is a mixture of many gases, say gas 1, 2, 3 and so on like this, each gas exerts its individual pressure. Okay, the pressure due to that individual component is known as partial pressure. Pressure due to individual component is known as partial pressure. Partial pressure. So gas 1 probably exerts a pressure P1. Gas 2 exerts a pressure P2. So this is partial pressure of gas 1. This is partial pressure of gas 2, and these pressures are independent of each other. Independent of each other. Independent of each other. Of course, we're assuming that they're all ideal gases and they do not interact with each other. The gases do not interact or react with each other. Right? So how will you find out this partial pressure? Partial pressure of any gas N, partial pressure of any gas Pn is equal to number of moles of that gas multiplied by RT over V. So there is a huge container with volume V at a temperature T. There's gas mixture inside. It has gas 1, gas 2 and gas 3, for example. How will you find out partial pressure of gas 1? Number of moles of gas 1, RT over V. Partial pressure of gas 2, number of moles of 2, RT over V, like this. Now, all these partial pressures, P total is equal to addition of all these partial pressures. How many ever gases are in here? And this is Dalton's law of partial pressures. This is Dalton's law of partial pressures. Now, let's say there are lots of gases in one gaseous mixture. So gas A or gas 1, gas 2, gas 3, 4, 5, like this, right? So you total up the number of moles. So number of moles of 1 plus number of moles of 2 plus number of moles of 3 plus number of moles of 4, like this, how many ever we have. This is the total number of moles. Total number of moles. Right? And if you place the numerator as number of moles of that one particular gas, okay, this is known as mole fraction of that first gas. This is known as mole fraction. So what is mole fraction? Mole fraction is number of moles of a gas, of an individual gas, divided by total number of moles in the mixture. Total number of gaseous moles, or total number of gaseous moles in the mixture. And this is one way of expressing concentration. This is mole fraction is one way of expressing concentration of an individual gas, of a particular gas, of an individual gas in a mixture. In a mixture. Now, what is the relation between mole fraction and partial pressure? So there's a bunch of gases, a mixture of gases, each one of them exerting its own partial pressure, contributing to the total pressure of the mixture. So how does number of moles of gas, or how many moles of gas and pressure, how are they related? Partial pressure of a gas, partial pressure of that one particular gas is equal to mole fraction of that gas multiplied by total pressure. So this is partial pressure of the gas N, partial pressure of the gas N. This is mole fraction of N of the gas N, and this is the total pressure. So in terms of questions, your question might be just a mole fraction question. So you might be given a number of gases, bunch of gases, and you might be asked for mole fraction. Simple, calculate the individual number of moles divided by total moles, right? Or they might ask you for partial pressure, in which case you will use this formula, partial pressure. Or given partial pressures, you might be asked for total pressure, or given total pressure, you might be asked for one of the partial pressures. So these are some kind of questions that you will face in this topic.